Hey everyone, welcome back. This is part 2 of the Attacking Entra ID series, and in our last video we did the outsider perspective. So that was tenant fingerprinting, user enumeration, blob storage recon, credential discovery in Git, password spraying, and device code phishing. So if you haven't watched that yet, I'd recommend you go back and watch that one first, because we're picking up immediately where that left off with access to the d.philbin account. So in this part, we're covering it in 2 phases. We're going to be doing additional recon now that we have access to an account, and then we're going to be performing privilege escalation using a misconfigured app registration. So by the end of the video, you'll have a global administrator token, which you can use to do further malicious things that we'll get into in the 3rd video. So just like last time, we're going to start off by running some enumeration using AAD internals. So now that we have credentials, we need to save an authentication token to our context in PowerShell. So we're just going to enter d.philbin at redact.com and then grab the password from last time, which has been updated. And now we have our access token saved to cache. So one thing I should probably mention that I haven't mentioned yet is that I changed the d.philbin account to be a guest user in my tenant. So this is just going to show the difference between what a guest user can see and what an actual member of the tenant can see. So we're going to start off with invoke AAD int recon as guest. So it takes just a second, but it comes back with a lot more information than we got last time when we were doing recon as an outsider. So just looking at it here, some key points are right here. So non-admin users restricted, false. Users can register apps, true, which is going to be foreshadowing for how we're going to escalate our privileges later. Directory access restricted, false. So any regular user of the tenant is going to be able to enumerate the entire directory. Guest access, normal. And conditional access policies 0. So this means that there are no conditional access policies in place. And these would be things like requiring MFA and MFA for admins, blocking non-compliant devices from signing in, blocking legacy authentication methods to sign in. And this could potentially already be a finding in a large organization because they're not using the security tools at their disposal that they've already paid for. We could keep looking through some of these values here. I don't think we're going to find out too much more information than we already have with this guest account recon. We're not able to fully list out the directory or the existing users unless we're able to sign into the Azure portal, as guest accounts are allowed to enumerate users within the portal, but not through the Graph API. And based on the fact that we can get around MFA to access the API like this, that's probably a good thing. So one really cool thing we can do with guest access that we can't do with outsider is send phishing messages through Microsoft Teams. So I can't demo this because my tenant doesn't have an actual valid license for Teams, but I'm just going to go through this repo and you'll kind of get the gist of it. So you'll invoke it like this, Python team fisher with the user you have access to, the password, the list of targets, which we can reuse what we found earlier through our user enumeration as an outsider, an attachment, so that'd be like your phishing payload, a message held in a text file, and this just shows their example here. And we can see that it does come through as a valid looking Teams message. And we're just going to assume that with our guest access, we were able to phish a user just so we can continue on and run Azure Hound after that. So it turns out I wasn't actually able to run Azure Hound because it hits APIs that are only available to the licensed tenants. I even tried running a fork of Bloodhound that uses road tools to collect the data instead, but I found that the fork wasn't really showing me the attack path that I was looking to show. So instead I just opted to explore the tenant using road recon instead. And I'll go into the Azure Hound Bloodhound combo in another video when I get that set up. So a bit disappointing that I'm not able to show all the tools that I plan on showing, but I'm sure I'll be able to demonstrate them in the future using Pwn Labs or another environment like that. So let's get back to it. Okay, I guess I'm not running Azure Hound like I planned, but we can accomplish the same type of things with road recon. It just won't give us that nice attack path graphically where you can see a starting point and all the steps to get to a finish point. So assuming we did compromise the d.shroot account with our Teams phishing attack, we can go ahead and authenticate to get the token that we would have gotten through phishing. There we go. We can see tokens were written to .roadtools_auth. And now we should be able to run road recon gather. And there we go. Over 1,000 HTTP requests were sent in order to generate our roadrecon.db file. And we can start up a web server to explore this. So road recon GUI. Now it starts up a Flask server on port 5000. So over here, we see that we get all the users now guaranteed, and we see that we missed Andy earlier in our user enumeration because he has a different email address format than the rest of the users. And that could be for a number of reasons, mostly mergers. So it's always a good idea to think of those things as you're enumerating as well. So let's take a look at the Dwight Schrute user that we were able to compromise. And we see that he's a member of 3 different roles. And the one that's really interesting is Help Desk Administrator. And that's because it can reset passwords for non-administrators and Help Desk administrators. So keep that in mind as we're looking through the rest of this directory, because we should be able to compromise any other account other than the global admin, which is the Michael Scott account. So after looking around a bit more, we see that we have an RPC or Redact Paper Company automation app, and we see that a custom owner is checked, which is very interesting. And we click on it and we see that that custom owner is the Ryan Howard user. So knowing that we have compromised Dwight Schrute with the Help Desk Administrator, and Ryan Howard isn't an administrator himself, we know that we can take over this account if we want to. But first, let's try to learn more about this RPC automation app. You can see that it has the service principal RPC automation app. And we want to see the roles that are assigned to it. So roles assigned to this principal. And we see that it has read-write access over the directory and read-write access over roles in Azure. So it would be one thing to have directory read all, but a whole another thing to have directory read write all. Simply put, that's our privilege escalation vector. I really just wanted to play around with the tools, so I made it very simple. This will allow us to add any role to any other user that we want, which would be giving Dwight or Ryan or any other account global administrator. So we're going to log in as the Dwight user, and the idea here is that we would have already got this access token from our Teams phishing step. So there we go. And if we print out the token, it looks like this. Now I'm going to copy and paste this graph API request, and this creates a patch request to v1 users for our .howard. And when we send it, no errors came up, so we assume that's successful. And then we do the same thing that we did for Dwight, and we get a new token for Howard using his new password. Now we can do another request to the Graph API and look for that Azure app that had RPC automation app as the display name, and then we can find the app ID. So now we can send this request, which will create a new client secret for that application. Just inserting the object ID here in the URL. And that new client secret will be held in secret text. And we can use this client secret to authenticate as the service principal RPC automation app. So I'll put the app ID as the client ID here in this request. And then we have the secret text here. And we should have a service principal token. So we're authenticated as the RPC automation app service principal, which we can remember has directory read-write access. So the plan was to give Dwight Schrute global administrator. So first we need to get his object ID. So now Dwight.id should give us his object ID. We need the ID of the global administrator role. And finally, we can grant Dwight the role of global administrator. So that's it for this video. Now that we have a global administrator token, And in the next one, I'm going to play around with some backdoors and continuing to follow that AAD internals kill chain. So we'll see you then.